University was a source of many interesting companies, not only legal, also of a promo, and Tomasz will tell you what's interesting in a promo has to say about the technologies that were started to be researched in the Military University of Technology, and now we are at the commercialization level.
Thank you. I want to start referring to the speaking of Mr. Jaworski, who said talking about the obvious things is similar for inventing time. Currently we are a company that is inventing a time, and we have skills and we have developed many synchronization systems that are currently used by NATO members in Europe. This year we have also supplied the military forces in Turkish, and we are a supplier for Israel, which is quite niche if you understand that this is completely Polish technology. But you know, talking about the synchronization is something more than just a military, because in our portfolio is also synchronization of Large Hadron Collider in CERN, and we are synchronizing the critical infrastructure. So once we have learned about the stability of time and frequency, we have decided to try to do something more advanced. We have put the first steps in photonics industry, and that was currently quite a long time ago, 20 years ago. So what we have done is we have taken a big fiber, very long fiber, and we have put a light in two directions, opposite directions. And what happened on the end? Well, it's interfered. What's special in that? This is so-called the Sanak effect, which has been invented 100 years ago to ensure that, you know, the space is something, the space is ether. Currently, it just proved that the space is not the ether, however, it has some properties. So we have very carefully observed what happens with the interference of during the Sanak interferometer experiment. We have read the parameters of phase and frequency. Mainly the phase is important for this experiment. And that is how we create the core fiber optic gyroscope. What I want to tell you here is a couple of the interesting applications for this device, because some of them you might expect. Of course, gyroscopes are commonly used for autonomous operation in aircraft, drones, ships. But I also want to let you discover some more application of this kind of the equipment. Here, this slide presents the seismograph acting as a seismograph. So what's the gyroscope supposed to do with the seismograph? Currently dealing with the high accuracy instruments as FOSREM, because that's the name of our project, is that we are able to sense angular speed. We don't measure linear velocity or acceleration. We immediately recognize angular velocity, so we are also able to compute angles. So if we are interested in the linear things, we have to compute. We do completely opposite proceeding computation than the normal gyroscopes are doing. So this seismology is something like, you know, spectrometry for the light. When you observe the space, the stars, you are able to say a lot of things about the chemical things that are inside the star, how old is the star, how far was the gravity, and so forth. We use the same technology for the seismograph, so we are able to sense a lot of things that are happening globally on the Earth. It's just a question of the accuracy. If you ask me what can I see from Poland in Japan, I tell you it depends currently what happens between Japan and Poland, but we can measure the shapes of the ground and we can make a lot of measurements on that. Mainly this high sensitivity of sensing has the application for new growing science, so-called microseismic sensing. It is used for discovering resources of gas, oil, thermal water, okay, and many resources that are very niche. The That's why I put the red color to highlight. We are very much interested in this direction. It's completely civil one, it's not a military. But the technology is still the same. It's still the same sensor, but applicable for the civil industry. There are more very interesting functionalities of this kind of photonic instrument. Suppose the wind farm. Considering the wind farm problem is that mostly they are located, you know, in the mountain where there is a strong wind on the sea area. So, you know, using those big winds, there are a lot of forces, strong forces. Some of them, they try to rotate the tower. And rotation of the tower can be quite dangerous. So we are able, using our sensor, to detect the rotary forces. This is also the reason why the new seismology science is so-called the rotational seismology. It is able to sense the rotary forces that the human beings, we always expect they exist. This is something what you, by the way, can see, you know, visiting the old Greece, old places where you see the columns and they are just rotating regarding each other. We expect that the reason is resistance, but in fact this is the result of their rotational forces. So very interesting application for the military for this instrument is that you can make an exercise like a computer game. Suppose you make you want to shoot on the polygon, on the exercise field with the missiles. So you don't need to use explosive materials to detect with a high accuracy what's your accuracy of reaching targets. It's enough if you put some of those sensors in the field and they can make exact measurement for you. Those are just the examples of FOSREM as a seismograph. Here are other examples, FOSREM as a gyroscope. First of all, because this is a fiber optic instrument, its operation works completely independent on the gravity of the Earth. It even works completely independently on the magnetic field. So this is why it makes it very attractive for the submarine and also for the space instruments. You know, in the space, the only reference frame for the FOSREM is currently the Einstein space-time. That's it. The Earth doesn't exist for us. We have to currently include as a kind of a noise, and we have to filter the rotation on the Earth. By the way, maybe you heard from the news that our Earth is not rotating constantly. It sometimes is rotating a little bit faster, sometimes slower. This is why you have what is so-called a leap second. So our 24-hour day is sometimes longer, sometimes shorter. Once per while, if this deviation is quite constant enough, there is an additional second added to our time scale. This kind of deviation is measured by this kind of equipment. Here I'm very proud to tell you that, you know, the FOSREM is the third sensitive. I mean, if we make a competition in sensitivity, FOSREM is the third in line, just behind the France and United States of America. So we have really developed something that is very unique and very high performance sensitive. How sensitive? For those who are not the physicists on this room, let me compare. We are able to sense a shape that is in dimension half size of helium nucleus. That's what we are able to sense. Okay? Thank you very much for your attention. I'm here on the Polish Space Agency stand, so you can come and ask me questions anytime. Thank you.